Loving viewers, greetings and welcome to Golden Age Technology on Supreme Master Television, featuring the first in a two-part program on the Solar Impulse, a Swiss solar-powered airplane that is reaching unprecedented heights in sustainable aviation. On July 7, 2010, in a memorable day in the history of manned flight, the Solar Impulse HBSIA prototype set off on an extraordinary trip. Pilot André Borschberg flew the single-seat plane through the day and using solar cell-generated electricity stored in onboard lithium polymer batteries, continued to fly through the night as well, a first-time achievement for a solar-powered plane. 26 hours after takeoff, the plane landed, even as its batteries were recharging in the morning sun. The voyage set 3 new world records for a solar-powered aircraft. 1, reaching an absolute altitude of 9,235 meters. 2, achieving a height gain of 8,744 meters. And 3, flying for the longest period ever, 26 hours, 10 minutes, and 19 seconds. The HBSIA is a large glider-like airplane with nearly 12,000 photovoltaic cells on its wings and tail. These cells supply electricity to the 4 10-horsepower electric motors which spin the craft's twin-blade propellers at 200 to 400 revolutions a minute. The solar cells generate enough energy during the day for running the motors as well as charging the batteries which power the plane at night. Solar Impulse SA was co-founded in 2003 by 2 Swiss aviation pioneers, balloonist Bertrand Piccard, who is also known for completing the first non-stop balloon flight around the globe, and professional airplane and helicopter pilot André Borschberg. Since the Solar Impulse project's inception, the team has grown remarkably. There are now 50 specialists from 6 countries, each playing an important part in the venture's success. The Solar Impulse project has gained widespread recognition for its accomplishments thus far, garnering the Swiss Solar Prize in September 2010, followed by winning the European Solar Prize in October 2010 in the category of Transport and Mobility.
My name is André Borschberg. I'm the CEO and one of the pilots of the Solar Impulse project. The objective of this airplane is to demonstrate that we can fly day and night using only solar energy. And that's what we attempted on July 7th, taking off 7 o'clock in the morning, and as we landed 26 hours later, we could demonstrate that this is feasible. And that was very, very important for us. Of course, important for the project because after 7 years' work, you fail. It's maybe difficult to continue, but you succeed. You demonstrate it works. But I think important also for the outside world because it shows that the technologies we have available really can help to save energy. And with this airplane, we have available from the sun energy to power the airplane, and the power we have is the power of a scooter, so it's extremely small. And so to fly with the power of a scooter, of course, you need to find the ways to save energy everywhere to make it sufficient. And that's the demonstration that we want to make with the Solar Impulse.
On September 21, 2010, marking 100 years since an aircraft first linked the Swiss cities of Payerne and Geneva, André Borschberg successfully piloted the first ever solar-powered flight across Switzerland. That day, the HBSIA flew from an airfield in Payerne to Geneva International Airport and back, and the next day from Payerne to Zurich International Airport and back. The event also marked the first time the craft flew amidst the busy air traffic of Switzerland's 2 major international airports.
I saw you land in Geneva the wingspan is enormous. Did they have to clear all the runways for you to be able to land?
Well, it's the similar size as an Airbus 340 or jumbo jet. So as we're using their infrastructure, that's fine. I think where we have been careful is not to be blown away by the jet blast of these big airliners. So we had a very good coordination with the airport. They invited us, in fact, as well as Zurich. So with this excellent coordination, there was no risk. But of course, there was a big emotion, in fact, to be able to land this huge airport and see this solar-powered airplane next to the existing airliners. So that was also very, very special.
While its 64-meter wingspan is comparable to that of an Airbus A340, a very large commercial passenger aircraft, engineers had to ensure that the Solar Impulse's weight was kept to an absolute minimum so that it could carry the 400 kilograms of lithium polymer batteries that provide energy during the night. In fact, this load comprises more than 25% of the plane's total weight. To achieve this goal, the Solar Impulse design team worked in harmony with suppliers in order to create the best and lightest possible materials and components.
As this airplane has a little power available, efficiency is the key word in our team and in our partners. And to make this airplane efficient, of course we try to make it first aerodynamically efficient. That's the reason why it's so big, because this big wingspan provides more lift, which you need in fact to carry the weight, and less drag, so lower losses. So that's the first reason. And then when we talk about efficiency, of course all the systems, you go for the best electric motors, but also the lightest batteries. And this has been developed with our partners and our suppliers. And the other element, which is of course extremely important, is the weight. If we want to reduce the energy consumption of a car, we have to reduce the weight of the car, which we can, and that's what we did on this airplane. We have an airplane of the size of an Airbus, but with the weight only of a mid-sized car, so about 1,600 kilograms. So the challenge was to reach this goal, in fact, this weight, how to build it, how to make it stiff enough, solid enough, because it looks fragile, but that's an airplane which can fly in gusts, so it's robust.
Bayer Material Science, a German company, is an official partner of the Solar Impulse project and is providing state-of-the-art lightweight polymer materials and energy conservation technology, as well as technical advice to the Solar Impulse engineering team.
For Biomaterial Science, the Solar Impulse project is absolutely perfect for us because this demonstrates how we can bring material benefits to lightweight structures, to this project. And at the end of the day, this is a project about the future. This is showing to people how behavior can be changed and how we can reach solutions to the problems of the planet which really are sustainable and workable for the future. So we're really excited to be part of the project. We're really enjoying the partnership and we look forward to a great success together.
While requiring advanced technology to meet many of the Endeavour's objectives, surprisingly some key components, such as the solar cells, the batteries, and the electric motor, were not specifically developed for the Solar Impulse plane and are commonly available to the public.
We use technologies which are also available on the market for everybody. The electric motors that we use could be used also on cars or on bikes. The batteries we use can also be used in transportation. So this efficiency that we have now available can be implemented in many applications on the ground as well.
Would it be possible to power a house with the solar cells used by the Solar Impulse aircraft?
Yes, they are not so different. I mean, they are differently integrated because these solar cells makes the upper part of the wing So we have a process of integration which is of course different than what you would do on a roof, but these solar cells are used on ground applications on houses. They have a high efficiency, though they are a little bit more expensive, but for places where the surface is limited and where in fact we need more energy collected from the sun, this is an excellent solution.
From the outset, the Solar Impulse project has had lofty ambitions, including a planned crossing of the Atlantic Ocean and a round-the-world flight. In 2011, the project's second plane, the HBSIB, will be built. It will have enhanced features such as a pressurized cabin and advanced avionics that will make non-stop transcontinental and transoceanic flights possible.
We did this flight through the night, and with this we could really measure everything on this airplane and understand where we can improve. And now with this data available, we start the design of the second airplane, and it will be built, then assembled, tested. So we plan to do the first flight around the world with this airplane around 2014. But in the meantime, we will continue flying this prototype airplane. We did a flight through Switzerland, landed in Geneva, landed in Zurich. So we went away from the nest we had here in Payerne. So that was a good experience, and we plan to visit some with the major European cities with this airplane. And the year after, maybe make the first transcontinental flight, so building our experience in using solar power to propel the airplane.
Through the dedication and leadership of André Borschberg and Bertrand Piccard, combined with their team members and partners, the Solar Impulse project will surely create new and exciting possibilities for the future of solar aviation and sustainable energy technology. We applaud all involved in the Solar Impulse project for continuing to set the standard of excellence in their field. For more details on the Solar Impulse project, please visit www.solarimpulse.com. Please join us again next week for the conclusion of our two-part series as we meet more of the team behind the HBSIA and the forthcoming HBSIB Solar Impulse aircraft. Joyful viewers, we appreciated your company today on Golden Age Technology. Coming up next is Vegetarianism, the Noble Way of Living, after noteworthy news. May your inherent divine wisdom and inspiration be your trusted guide in all your endeavors.
For more details, please visit www.suprememastertv.com/GAT